Okay, so next I want to look at this problem of creating these transaction numbers that are going to work across all the different account instances. In other words, if one account makes a deposit, and let's say my transaction number, my last transaction number was 100, that account's deposits confirmation number should have a transaction ID of 101. If another account does a withdrawal, then its transaction ID is going to be 102, and so on. So I want this transaction number to be basically at a class level for my account. So this is an object-oriented course. So the first thing you might be tempted to think is, well, I need a class. So let's go ahead and try that approach. So let's create a transaction ID class, and it's going to have an init and self and start ID. That's going to be my starting ID. So when I start my program, I'll say, okay, my start transaction ID is 0, let's say, or it's 100, or whatever the number I want it to be. So I'll go ahead and store that in the instance, right? So I can create later an instance of the transaction ID, and then all I need to do is create, let's say, this method called next. Now this is not the special method done to next. This is just a method I called next. And all it does, it increments the counter by 1, and it returns self._start ID. Okay, that's all that class does. So that will work pretty well, because now we can create an account class this way. We can create a class variable called the transaction counter, and we can say it's an instance of the transaction ID class, starting, let's say, at 100. And let's go ahead and just make a dummy method here to make transaction. And all it's going to do here, it's going to get the new transaction ID by calling the account.transaction counter, right? That's an object, that's an instance of the transaction ID, and it just needs to call the next method on that. And that is going to increment this transaction number by 1 and return it. Okay, so if we do this, we can now create two accounts. Let's go ahead and create A1 and A2. So now we have these two accounts, and we can start making transactions. So we can say print A1 dot, because remember, the make transaction is just going to return this, well, it will return it once I actually return it. So it's just going to return the new transaction. Okay, so we're going to say make transaction. Then we'll switch over to the second account and also make a transaction. And then we'll switch over back to the first account and make another transaction. And let's see what happens. Well, as you can see, we get transaction ID 101, then 102, then 103. So this is working pretty well, right? But if we think about this more, we really don't need a class to solve this problem. And this is something I think that comes up often, especially in kind of more intermediate or beginner Python developers, and especially if you come from a background like Java, for example. You tend to think that everything must be an object, and you solve every problem by using a class and a custom class. So the answer is no, not really. There are many things that we can solve in Python without using a custom class. Obviously, everything's an object, but we don't have to use classes all the time. If we think about this, what is our transaction ID? Well, all we really need is an iterator, right? We just need something that returns a new value each time it gets called. Well, that's the iterator protocol. That's exactly what we can do. So we don't need a class for this. We could do it this way. We could say def transaction IDs, let's say, and we'll specify the start ID. So here we're defining a function, not a class. And then we're going to make this basically an infinite generator, an infinite iterator, right? So we're going to start ID plus equals 1. We're going to increment the start ID by 1. And then we are going to yield the start ID, right? So we're writing a generator function. And it's going to be infinite. So we can start our generator by saying, okay, T, let's say, equals transaction IDs, right? So now we've created an instance, and I need to pass it an initial value. Okay, so now T is a generator, right? We can see T is a generator object. And we can start calling next on T. And we get that, 101, and then we call next again. We get 102, and so on. So we're getting the same effect that we had with this transaction class, but we're just using a generator object for that. So how would we use it? Well, we can go ahead and say account, and then we can just say transaction counter equals transaction IDs started at 100, for example. And then we have to define our dummy make transaction method. So let's go ahead and do that. I'm going to say new transaction ID equals next on the account dot transaction counter, right? Transaction counter is a class attribute, and we could probably make this private and so on. And then we can just call it this way, and then we can return it, okay? We do whatever we need for our transaction, and at the end we'll return the confirmation code. Here I'm just going to return the transaction ID. And again, we can do exactly what we did over here. So let me copy paste. And we'll create the two accounts again using the new version of our class. And again, I'm just going to make the same transactions. Like so. And as you can see, we have the same result, 101, 102, 103. So that's great, right? We were able to simplify this to something a little simpler, just using a generator. But we can take this one step further. We have the itertools module, and the itertools module has a generator in there called counter, which does exactly what we wrote here. So instead of doing all this work, right, with creating this generator ourselves and then applying it in the class, we can do it this way. We can import itertools, and now we can just go straight into our account. So let's create the account, and I'm going to copy paste all this code because really nothing changes except for one little thing. This is no longer that. It's just going to be itertools.count, and let's say starting at 100 as well. Okay, and I have to spell it right, count, okay? And this count is going to do essentially what we wrote over here. So it's already built in to the standard library, right? It's basically going to do this. And it actually can do more. You can specify step sizes and so on. And if you need to refresh your memory on it, you can just do a help itertools count, and you'll get the help on it, right? So you have a start, you have an optional step, and so on. So let me delete that, and let's go back to this code. So now let's go ahead once more, create two instances of the account, and then let's make those transactions. And as you can see, we have the same effect, right? The only difference is that this one starts and includes 100. Ours, I set the starting point to be 100, but it calls next, so it goes to the next one right away, to 101. That's the only difference between the two. So as you can see, we don't have to create a class to solve this problem. We were able to solve it by just using the itertools module and the count in there, right? Or if you don't want to use that or you weren't aware of it, at least make sure that you use something like this generator approach instead of yet another class that has to be documented, that people have to understand what it does, right? It's more work, there's more overhead with classes because there's a lot of things we didn't do in here. We didn't implement equals, we didn't, if we do that, do we want to do that? Do we want to implement, a hashing? Do we need a representation for it? Because, right, I'm calling the next method, but the transaction ID has a representation, it has a current state, what do you want to do with all those things and so on. There's always more overhead with classes. All right, so that's how we're going to handle transaction numbers. Thanks for watching, and I'll see you in the next video.